Welcome back, everybody. This is Chapter 7 review for the Algebra 1 exam. All right, so Chapter 7, let's think back to Chapter 7 and what we learned way back in Chapter 7. Well, Chapter 7 was split up into two big chunks. The first half of Chapter 7 and the second half of Chapter 7. We actually did two different tests. First half, second half. So the first half of the Chapter 7, first half was all exponent properties. Right? It was all exponent properties. Section 7.1 to 7.4, all exponent properties. What do I mean by that? Well, if I had x to the 0 power, what is anything raised to the 0 power? 1. Anything raised to the 0 power is 1. Doesn't matter what it is. Anything raised to the 0 power is 1. What would have happened if I take x to the negative 1 power? What do negative exponents do?
They cancel out. Aren't they undefined?
Negative.
Yeah.
One.
They go on the bottom.
They go on the bottom, right? So this would be like 1 over x to the positive first, right? Negative exponents change position whether it's top to bottom. Also, if you have x squared times x to the 5th, what do you do with those exponents when you multiply? Well, he's very excited about that. X to the 7th, you would add those exponents together. He just wanted to get on the video. Now, what would happen if I divide exponents? We subtract. So 7 minus 3 would be 4. Okay, so what would happen if I've got x to the 2nd to the 4th? What happens when I take power to a power? Multiply. Right, this would be x to the 8th. This is review. Sorry, I'm just getting really excited about it. So we've got product property, division property, power to a power property. There's also this power of a product. Like if I've got a times b to the 3rd power, if I've got two things that I'm multiplying and I'm raising that entire thing to a power, all I need to do is just distribute that power. So that would be like a to the 3rd, b to the 3rd. Same thing for a quotient. If you've got like a over b to the 5th power, all you would need to do is, after you reduced as much as possible on the inside, just distribute that power. A to the 5th over b to the 5th. And I'm trying to think, I think that's it for all the exponent rules. Yeah, yeah, that's a good point. If you have a over b to like the negative 1 power, you've got a fraction and you raise it to a negative power, you just flip the insides and make the exponent positive. Take the reciprocal. That was all the first half of Chapter 7. Okay? That's all the first half of Chapter 7. All of those exponent rules. So there are going to be questions. This is like the furthest back that we will go. We did a little bit of Chapter 6 within the second semester. We've decided to make it a clean slate studying at Chapter 7 because we kind of like split Chapter 6 into the second semester. So we just said, you know what, we're going to chop it right here at Chapter 7 and just start fresh here at Chapter 7. So that's the first half of Chapter 7. Let's take a look at the second half of Chapter 7. The second half of Chapter 7 was all about polynomials. Now, this is the chapter where we started to name them, like quadratic trinomial or linear binomial or something like that, right? We named polynomials, but what we really focused on was adding, subtracting, and multiplying. right? That's really, sorry about my messed up G. That's really what we were focused on in the second half of chapter 7. And mainly the multiplication. This is back when we learned to FOIL. And that's what I'm talking about here in the second half of chapter 7. I will tell you this right now. There is none of those like naming questions on the exam. It's not on the exam review, so therefore it's not covered on the exam. Okay, there's no naming on there. This is when we first learned how to put things into standard form and whatnot. So we'll talk about that here. So that's chapter 7. That's chapter 7. So all the questions I could ask about chapter 7. So let me show you some examples. Now, when we do examples in here, we're going throughout this week and I show an example on the board, I want you to copy it down and do it with me. So everybody write down 3 to the negative second power. And we'll do this one together. This is how each day will run. We'll go over what chapter we're reviewing that day, and then we'll just do some problems. All right, well, I've got 3 to the negative second power. That's like 1 over 3 to the positive second power. So 1/9, right? Remember, we talked a lot about how negative exponents are fraction exponents, right? They turn something into a fraction. Not a negative number, but a fraction. Negative exponents are small numbers. So 3 to the negative second power is like saying 1 over 3 to the positive second power. 3 to the positive second power is 9, so it's really like 1 over 9. 1/9 would be 3 to the negative second power. Go ahead and write that down. I'll give you a second for this one. Don't remember how to do these, right? Remember, for these problems where I just say simplify like this, it's just you have to use all of your exponent properties to figure out what happens to each piece. Like for example, I've got 5x to the 0. What happens with that x to the 0? Maddie?
Turns it to a 1.
Turns it to a 1. Thank you. She had raised her hand back here. Thank you, Riley. Turns it to a 1. So essentially, it like cancels out, right? A lot of people have been saying it goes to a 0. No, it doesn't go to a 0. Because if it truly went to a 0, I'd be multiplying all my stuff on top by a 0 and it would cancel everything out. That's not what happens. The only thing that happens is this goes away. That x to the 0 cancels out. The 5 stays there. The 5 is not raised to the x to the 0 power, just the x is. Now, is the y happy where it is? No. To make it happy, you move it. So it's not happy on top. It's got to go to the bottom, makes it happy. Is the z happy on bottom? Move it to the top, make it happy. Turn it positive. There we have it. So negative exponents are not happy where they are. Change where they go. Okay? Let's keep it going. 4x to the third, y to the negative first, raised to the second power. 4x to the third, y to the negative first, raised to the second power. Now, I can distribute this exponent into my product. I can do that. Why can I do that? Because this is all multiplication, I can take this power and distribute it in. If there were any addition or subtraction signs down below, I would not be able to do that. But since it's all just multiplication, I can distribute the power. What does that mean? That means I take 4 squared, x to the third squared, y to the negative first squared. And I'm showing all the work there. But what really happens to my exponents? What should the exponent on x be? X to the 6th, right? That should be 4 squared is 16. X to the 6th, y to the what? Negative second. Can I leave my answer like that? No. The y has to go down into the denominator. So this becomes 16x to the 6th over y to the positive second. Okay, let's take a look at another one. Move this up here. If anybody was still writing that last one down, it is for you. Again, you notice how there's no addition or subtraction signs inside the parentheses? That means all I need to do is just distribute that power to the inside here. Here, here, and here. All right, well, what's 5 to the 3rd power? Don't say 15.
125?
125. Did you do that from memory, Belush?
No, I just heard someone say it.
Oh, you're secret.
No, but you see how I stuttered to act like I did it in my head?
X to the 3rd. Y to the 12th. That's it. Nothing left to combine, nothing left to do past that. All right, so that's the first half of chapter 7. Let's take a look at the second half of chapter 7. Add, subtract. Now, I'm not even going to cover an addition an example, because honestly, addition is just basically combining like terms.
I thought we were just covering the second half of.
No, that was all, what we just did was all exponent rules. Every example that we just did was all exponent rules. Now we're getting into the second half of chapter 7, where there's the add, subtract, multiply polynomials. So this is adding, again, adding is just combining like terms. Subtracting, what do I do with that negative? Right, I distribute the negative. Right, I distribute that negative in, and then I just combine like terms. So I've got 7x to the 5th minus x squared. Again, that first polynomial doesn't change at all. But then this turns into negative x to the 5th minus 5x to the 3rd plus 6. And now we just combine like terms. 7x to the 5th and a negative x to the 5th. 6x to the 5th. What should come next after I do that? The x to the 3rd. What are we putting it in? What's that called? Standard form. Go in descending order in terms of the degree. That was a big part of chapter 7. We didn't even learn what standard form was yet. So I hope you see that subtraction is really easy. All you do is just distribute the negative and then combine your like terms.
Can you combine them? If it has a negative, do you have to subtract it?
Yeah. Yeah, basically you combine it with whatever's there. Like this like the 7 and the negative 1 is like subtracting it there.
But what if the exponent is negative?
Oh, what if the exponent is negative? Then you have to have another matching negative exponent. Yeah, I wouldn't do that to you then. Let's take a look at another one. Let's take a look at what happens when we multiply. Instinctually, what do you think you should do? What does it feel like you should do with that 7/8 to the 3rd? Exactly. We're just going to distribute it in. Which one?
I thought you were going to say, oh, well, that's not how you do it.
No, that's right. You had it right. You're fine. You're good. So we take the numbers, multiply them together. 7 times negative 4 is a negative 28. A to the what?
20, or 15? 15.
Negative.
That's way out. 8. Remember, multiplying bases means you add exponents. It's when you raise a power to power, that's when you multiply the exponents. And then we get 7 times 3 is 21. Give it a second shot. A to the what? 6. There we go.
You're clever.
Now, can I combine those two terms? Can I make that a negative 7, a to the 14th? No. Not sure. No, you cannot, because these are not like terms. I'm adding here. I'm not multiplying. I could multiply in, but I can't add those things together. I can't combine those like terms. So I'm done. Okay, let's just keep doing the distributive property. I'll give you a second to write that one down. Please write this one down. This is important here. This is one of the more difficult ones from this chapter. But honestly, if you stay organized, it shouldn't be that difficult. So all I'm going to do is multiply in the first term and then multiply in the second term. What do I mean by that? I'm going to distribute in the first term and then I'm going to distribute in the second term. So let's go with the first term. 6y times y squared.
6 to the third, y squared.
Good. 6y to the third. 6y times negative 3y. Negative 18
Y squared.
y squared. 6y times 5, 30y. Then I do the exact same thing with the negative 4. Negative 4 times y squared is a negative 4y squared. Negative 4 times negative 3y is a positive 12y. Negative 4 positive 5 is a negative 20. And then I combine like terms. Don't forget to combine like terms in the end. My first term has nothing to combine. The negative 18 and the negative 4 make negative 22. The positive 30 and the positive 12 make positive 42. Bring down the minus 20. That's my final answer. Yeah, these require a lot of work. One last problem here. Now I'm going to multiply this together. Let me ask you this. Can I distribute my power in? No. And the reason I cannot is because of this plus sign right there. That's why you cannot distribute it in. That's why you have to use the FOIL method. And because technically it's 3x plus 5y times 3x plus 5y. And let's FOIL it out. 3x times 3x, 9x squared. 3x times 5y, 15xy. 5y times 3x, 15xy. 5y times 5y, 25y squared. This should seem familiar to you because we just did this when we multiplied with radicals. So we get 9x squared, 30xy, plus 25x, y squared. All right. So, I'm going to pass out the exam review packet. The rest of the period is yours to work. Please don't try to pack up early. You have plenty to do. Yes, quiet, folks. Again, this is 4 homework checks, so this is really important.
You get 44 for it?
Yes.
For one
No.
time?
Yeah, it's separated up there.
So we have to show the whole, all the paper?
It says show all work and answers on a separate sheet of paper. Please do not try to do this all. Please do not try to do this all on this paper. Alright.
We get like 40 points for chapter 7, chapter 8, chapter 9, or so.
Then we need 10 points each. Thank you.
Oh, so
Yeah, even I know that.
Thank you.
Okay, so I want you to get to work. This is how each day is going to run. We'll go through a chapter, and then whatever time remaining, you'll have the rest of the time to work on your homework. Sound good? And again, I strongly encourage you to work forward, work ahead.